Point to that 1/2. What does that 1/2 do? Amplitude. Does that mean my amplitude is negative 1/2?
No.
It's always positive. What's that negative do though?
Flips it.
It flip it. So I might actually put it flips it. What does that 3 do? It affects the period. Remember the period? No, that doesn't say period. That says period. Our period is 2 pi divided by b. That is your b value. So we would have 2 pi divided by 3 for the period. Negative pi over 6, left or right? Right. So it's going to go right. Negative 1, what's that going to do? Down. Now, a lot of times on tests, I'll ask for like the amplitude, the period and stuff. If you do this every single time, you don't have to worry about reading that stuff. You'll already have that written down. You don't have to go back. Everything's pertinence on there. That it should go right, it should go down, it should flip. And in fact, if you just knew those things, right, down, and flip, that's the one that matches it. That's what JP's like, I could visualize it. But we have to be able to visualize it, so when we're done, it actually matches what I'm going to visualize. All right, a lot of us in the homework miss this next step. You have to have your x and y axes labeled. That is points. That's why we did that half multiplied by 3. Half multiplied by 3 says, find your period, count out 4 tick marks. 1, 2, 3, 4, and put that 2 pi over 3. 1, 2, 3, 4, 2 pi over 3. If I was wasting your time, I would not make you do this. But this is going to be part of your points. Now, we half that. We half that to get our second tick mark. What's 1/2 of 2 pi over 3? It's pi over 3 because you multiply by 1/2. So the 2's cancel out, so we should add pi over 3. Pi over 3 times 1/2 is pi over 6. Pi over 6 times 3 is 3 pi over 6, which you could put 3 pi over 6. There's nothing wrong with that. But we could reduce that down to pi over 2 as well. Now let's label this 1, 2, tree, -1, -2, -tree. And now I got everything labeled. I don't have to worry about that. I'm done with the labeling, done with the period. Now what I highly suggest you do is start focusing on knowing what a sine graph looks like. So you should know that sine graph starts at 0, 1. Oh, it starts at 0, 0. So sine goes down, up, down, and back up. So we should be able to picture that. Now I'm going to picture, wait, so it always starts at 0, 0. So I'm going to do light blue here. It usually goes up, but now the amplitude is 1/2. So I'd kind of picture it going at 1/2, but someone said, which direction should I actually go? I should go down instead. So my thought is, well, normally it goes up to 1. Amplitude's 1/2, so it's there, but it's -1/2, so it's going to go down. So this blue dot right here is going to actually be my down. Then it comes back up to 1/2 and back down to the sinusoidal axis. Those first 2 points should be key to any graph. Where does it start? Is it sine or cosine? And what's my next point? If you get that, you know what sine and cosine looks like. The rest is just following the pattern. All right, so I tackled the amplitude. Now I have to go right pi over 6. That means I'm going to pick the point that's on the y-axis and shift it right. So I'll take that first point. Maybe I'll do it as pink. I'll move everything pi over 6. So that means if I move this one right, 1 tick mark, I'll move all of them right, 1 tick mark. Now be careful here because you should be able to, if you look up here, does anyone see a mistake I made? What'd you see? I messed up the second point. Look how this is 1/2 above, this is 1 below. We should be able to picture that sinusoidal axis and go, oh, okay, there's a mistake there. And usually I wouldn't check that till the very end. So I actually needed that pink point right there to be halfway. Now the very last thing I have to do is I have to shift everything down 1. My advice to you, if I shift everything down 1, I'm going to draw a sinusoidal axis that's down 1. That's my sinusoidal axis shifted down 1. My points should go up and down along that sinusoidal axis. So if I move all of those pink points down 1, maybe I should pick a different color. Maybe dark purple will show up better. Dark purple is my final answer. I should point an arrow to it and put Mr. Pabian, that's my final graph. I'm good. Now we go to what JP said. He said he could visualize what it looks like. It went right, it went down. Did this go right and down? Yes. Okay, now double check the amplitude. The amplitude should be 1/2. That means it goes halfway above my sinusoidal axis. It does. Halfway below, it does, and it's flipped. It's very easy to check your graph at the end. And if it's wrong and you don't have time to fix it, just go, Mr. Pabian, it was supposed to do this. It didn't happen. I don't have time to fix it, but I know it's wrong. Yeah.
How do you know that line?
The sinusoidal axis? How do I know it's there? Your sinusoidal axis will always be affected by this D value, whether it goes up or down. So you see how this went down 1? That means your sinusoidal axis must go down 1. So right here is -1. If this would have been +3, I would have counted up 3, and that would be where my sinusoidal axis would be. All right, questions on the bell work? Then let us go over questions on the homework minus the last 2. Let's handle anything but the last 2. We will go over the last 2, but let's do anything besides the last 2 first.
So it's like
Cosine? I'm sorry. So any question you want except for the last 2, because we will go over those in class as it is. Yeah. Number 7. Was that the one where we had to, am I on the right one where it says determine the amplitude, period, and phase shift?
Yes.
Wait, no, I'm on the wrong one, aren't I? Here we go. I had the wrong number 7. It just happened to be in the right place.
Why is the lessons so short today?
Number 7, we have the amplitude, the period, and the phase shift of each one, right? So we are given negative cosine. Of x over 2 plus 3. All right, so amplitude. Let's handle that first. Amplitude is that number that's out front. What's in front of cosine right now? 1. So would my amplitude be -1? It'd be +1. All right, now we have a little bit of problem because we get to the period. The period is 2 pi divided by b, and b is whatever number's in front of x. It kind of looks like there's no number in front of x, but there is. It's not 1. I'm going to rewrite this in a different way. I'm going to rewrite this as negative cosine of 1/2 times x plus 3. Because 1 over 2 times x is just x over 2. There's a 1/2 in front of it. We just don't ever leave it that way because we can condense it to x over 2. So if you ever see a fraction, we can just pull that fraction out front using multiplication so we can see what it looks like. Now, the amplitude value for b is 1/2. So the period is going to be 2 pi divided by 1/2. This is the time where you kind of have to know that keep, change, flip. Keep, change, flip says keep the top of the fraction, which is 2 pi. Flip the bottom fraction. So instead of 1 over 2, I'm going to have 2 over 1. And that's going to equal 4 pi. Then we should know that it goes up 3, right? Up 3. Does it go left or right? No, because you have to have a plus or a minus after the x. Is that a little clearer? Okay.
I'm just confused.
All right. Are we good on that one? Know how to do that. Because you might know how to do a problem, but you come across this one, you're not quite sure how to rewrite it to match what we did. All right, other questions? Number 10. Number 10 says determine the amplitude, period, and phase shift of each of those functions as well, correct?
Yeah.
So our amplitude for that one, do you agree our amplitude would be 2? Yeah. Okay, so for number 10, our amplitude would be 2. Let's go through the period together. I'm always going to write this. Period is 2 pi divided by b. What is our b value in this one? Pi over 2. It is an entire thing. So it'd be 2 pi over 2. Keep, change, flip says keep the numerator, flip the denominator. Now, just as a hint for multiplication, you can picture 2 pi as being 2 pi over 1. We multiply straight across. So we're going to have 4 pi divided by pi. Because it's multiplication, our pi's would cancel out. We're left with just 4. That's okay. If the period is 4, I just count out 4, write a 4, half, half, multiply by 3, and you'll find out it's just 1, 2, 3, 4, which is fine. And then we're going to go left. I'm actually going to write this out real quick. So we have y equals negative 2 cosine of pi over 2x plus pi. The period is correct, but right now it kind of looks like we go left pi, correct? Who asked that question? Doesn't it look like we go left pi?
Yeah, I feel like
We don't, because we have a period change. And if we have a period change, you must rewrite this. You must pull it out using factoring. You have to see how that new period affects that phase shift. So this must be rewritten as negative 2 cosine of something times something inside here. If there's a period change and a phase shift, you must rewrite it. It must be either in this form or you have to rewrite it in this form. So to rewrite this in this form, I need to put that pi over 2 on the outside, because we need x alone. And then just a reminder that when you factor something out, you're using division. So let me put this in red. What goes in that box is the original pi divided by what we're factoring out, which is pi over 2. If we did keep, change, flip, we'd have pi times 2 over pi, which just equals 2. So this actually goes left 2. A lot of us are going to lose that point on the test. I don't pick one this hard on the test. I pick one that's kind of easy to factor out. I'm not testing your factoring skills. I'm checking to see if there's a phase shift and a change of period that you understand that it must be in that form. Most of the time it'll be given to you in this form, but definitely in the test, at least there'll be a couple problems where it won't be given in that form. Is it earth-shattering if you don't get those? No, you could probably still get an A. It's just basically the thing that divides someone that has an A to a high A. Okay, other quick questions? Okay, then let's dive into today's lesson. And today's lesson actually starts off with number 11 on last night's homework. Number 11 on last night's homework. It says that we have a sine function that has the period of pi. It gets shifted left pi over 2. And it has a range of 3 to 7.
it shifts left.
We know it shifts left, so we must have something that's like x plus pi over 2. So at the very least on the test, you should be able to put sine of x plus pi over 2. But let's get the rest of those. So we know that this affects our c value. This was the period, and this is our amplitude. Let's start with our amplitude. Your amplitude actually gets you 2 values. Your amplitude will get you 2 values. So I'm going to picture this. So an amplitude of 3 and 7, that means if I have a number line or an xy axis, and I'm at 3, 4, 5, 6, 7. My graph cannot go below that part, and my graph cannot go above that line. That means your graph is looking like this. I don't know where this is, so I'm just showing you an idea. Your graph is bouncing between these 2 points. Now, if you remember, your sinusoidal axis cuts right through the middle of this graph. Let's note real quick here that the distance between 3 and 7 is 4. The distance between those two is 4. That's important for us for a couple reasons. First of all, what's the amplitude? Guess someone thought of the right answer. It's going to be 2. It's going to be half your range distance because it's from your sinusoidal axis to the highest or lowest point. So your amplitude, which I'll do in purple, is this distance right here. This would be our amplitude, which is 2. It's 2 above and 2 below. Your amplitude is that number that goes out front. So if I'm going to start writing this equation, I can already go, oh, this is going to be y equals 2, because our amplitude is 2, and then I'll have sine.
So how do we know it's sine?
It says it's sine in the directions. If you read it, it says it wants sine. Or if I ask for cosine, it'd be the exact same steps, except we put cosine in there. So the directions say specifically I want a sine. All right, the next value I want to find is the period. I'm going to hold on to the period. That's the hardest one to find. So let's hold on to that one. And let's just go, we'd have x. What would the d value be? I'm sorry, c value. We'd have x.
Minus pi over 2 plus. No one did.
It would actually be plus pi over 2, though, because we want it to go left. This will make it go left pi over 2.
Why?
What was that?
Why do you meant to go negative?
It said it in the. I told you before you left that if it's negative pi over 2, because this isn't in the equation, so it's just telling you it goes left pi over 2.
Oh, so it's one. So it's positive. It goes right.
Yeah, if I said it goes right pi over 2, then that would have to be a negative. Yeah. Okay, so real quick. We drew the picture, got our amplitude. That became my A value. I went left, so I just put pi over 2. Let's get our D value second. That's if it goes shifted up or down. That's why I wanted you to draw your sinusoidal axis. Your sinusoidal axis tells you how far your graph got shifted up or down. So if you look at the sinusoidal axis that I drew halfway between here, that's at the point 3, 4, 5. Right smack in the middle is 5. That means you got shifted up 5 units. Up 5, that's the D value. So we're going to attach a plus 5 to the outside. Remember, your job is just to discern what's happening here. I need to know if you're going left, right, up, down. Now we get to the hardest part, and that is the period. Every time I do a problem like this, you have to write out what period equals. Period equals 2 pi divided by b. It equals 2 pi divided by b. So whatever number is here would also be here. We don't know what the b value is, but we know the entire period is pi. So we're going to take that pi and plug it in for the period, because we now know the period, not the b value. So I'm going to rewrite this equation. I'm going to take that pi value they gave me for the period, and I'm actually going to fill that in for the period. So now I have pi equals 2 pi divided by b. It's going to equal 2. You can use cross multiplication, or you can just multiply both sides by b. That's what I'm going to do real quick, but you should see it's 2. But let's say you have to do the math. I'd multiply both sides by b. That would give me b times pi equals 2 pi. I would divide both sides by pi, and we come up with b equals 2. That 2 is going to go in that space I just provided. Left, right, up, down should be easy. Sometimes amplitude can be tricky. The period is almost always tricky until you write down that equation and you actually solve it. All right, that's all I'm doing for this one. You probably want to do the next one for practice because the next class we have is a quiz. And we'll have one like this on the quiz. But more specifically, we'll probably have one that looks more like this on the quiz, which is actually asking the same question. This time I'm giving you a graph, and I'm asking you to come up with an equation for that graph. Specifically, I'm asking for a sine equation. Let's all look up here. This is important. This is on the quiz. For those of us that didn't do well in the last quiz, this quiz also is not retakeable. And if we're failing, we're at that 3-week mark, I think. Like grade reports go out and stuff. You're going to go out with a failing grade. So let's actually focus on this test and do well, or quiz and do well on it. Now, remember what sine looks like. Sine starts at 0, it goes up and comes back down. Doesn't this look a lot more than what sine normally looks like? Because once again, for those of us doing our homeworks correctly, we should recognize that sine looks something like this, where it starts, it goes up, and it comes down, and it looks like that. That's one full cycle. Either it goes up or it flipped and goes the opposite direction. Your job is to look at the graph I provided you and locate something that looks like an entire sine, a cycle of sine. That means you have a start point and an end point where it starts repeating itself. So if I look at this graph and I look from here to here, that's one full sine curve. So that's what I'm looking at. I'm saying, well, if I picture from here to here, that's one full sine curve. Our job is to forget about the rest. So it's kind of like the rest is gone. That's one full cycle of sine. That will give you one answer. Can we all look up here real quick? I want all of us, no matter how good we think we are at this, I want us to look at what I just did here. I don't care if you're not sure what's going on. I'm not going to write the equation yet. What I'm going to tell you is this graph right here got shifted left and dropped. Does that make sense that this graph got shifted left and dropped from a normal sine curve? Okay, let me bring back this. Keep looking up here. Keep looking up here. Someone else in this class might have pictured this one first. They might have said, well, that's one full cycle, and that's what I'm going to focus on, Mr. Pabian. This will get you a correct answer as well. However, this one's shifted further left, it's down, and this one would be flipped. So you'd have a negative up front. Both these would get correct answers, but they would be different answers. They'd both be correct. So what I'm putting out here is you two can do it correct, but you have two different answers. If you look at the answer key, maybe yours is correct and mine's based upon a different image of it. Your job is to look for one full cycle. I usually pick the cycle that I don't have to flip it. So I'm going to pick that one. That's the one I'm focusing on for the rest of this. Now we have to come up with our equation. Now, we can do this however we want, but I always draw my sinusoidal axis. So my sinusoidal axis is the one that goes through the middle. Your sinusoidal axis will get your amplitude, and it'll also get your shift up or down. What's the amplitude of this one? How high above or how below? Mercer? It's going to be 2. So if you don't know anything about anything else, you know that that's 2, so our amplitude is 2. If your amplitude is 2, that means your A value equals 2. So we can start writing our equation. We can say, okay, y equals 2 times sine. I'm going to skip the B value. I always do that at the end. You can do that whenever you want. Okay, I also said that the amplitude gets you your D value. That's why I skip right to the D value. Draw my sinusoidal axis, gives me my amplitude, get you the D value. What would I write outside of this? What would the D value be for this one? Read. -1. It'd be -1. Look at that sinusoidal axis. That is one value down. So the D value equals -1. So we're going to put a -1 at the end. Next kind of easy one is sine usually starts at 0, 0. Now we got shifted down 1. And we went left. Well, if this is pi over 2, what's halfway to pi over 2? Pi over 4. So it goes left pi over 4. To go left pi over 4, do I want a minus or do I want a plus? So we're going to make this plus pi over 4. I'll do a different color maybe.
How is it pi over 4?
We'll look at that. So we know they labeled this as pi over 2, right?
Yeah.
And this is half the distance of pi over 2. So I'd multiply pi over 2 by 1/2.
The point shifted over 2.
It didn't shift over 2. It's right here. It just got shifted 1 and then down. I'm looking at this point right here. Because that's the graph I have to focus on. That's what we talked about before. That you need to pick out one full cycle of, this is actually a cycle and a quarter of sine. You need to pick out just one full cycle before it starts repeating. If you picked out this cycle here that started here, that would shift 1, 2, 3 pi over 2. So you'd have a slightly different answer, but it'd still be correct.
Okay, so you just picked a different one.
I picked a different one than you were looking at. Yeah, Ernie.
Would it be, for A, would it be negative 2?
It would only be negative 2 if it's flipped. You see how this goes up first and then down? If you pick this point, so I shaded in the part that I was focusing on. If you shaded in this part, you would have a negative out front.
Would it be correct?
I usually avoid, it would still be correct, yes. So if you pick this one, it got shifted 3 pi over 2, and it'd be negative. Those would be the two different values that we'd have, but it'd still be correct. I usually pick the one that can stay positive, it just so I don't forget about putting a negative out front. All right, now the hardest one is our b value. Our b value comes from the fact that anytime I see this graph, I'm going to immediately write period equals 2 pi over b. Because this distance here is the period. So let me go in orange. So if you remember from the first day we did this, I said how long it takes till it starts repeating itself is the period. So you need to figure out how many units it takes to get from here all the way here. It takes 4 tick marks. How far is 1 tick mark? Pi over 4. So what happens if you have 4 pi over 4s? You have pi as a distance. You have pi as a distance. So the period here is going to be pi units. So it might just be you adding that this is pi over 4 plus pi over 4 plus pi over 4 plus pi over 4. That would give you a pi. Are we all clear on the period being pi?
Yes.
Now the biggest mistake I see is people take pi and go, oh, that's my b value. That is not your b value, that's period. That's why I'm going to tell you, write this equation every single time that period equals 2 pi over b. Fill in pi equals 2 pi over b. What does b equal?
2.
B equals 2, and then we can plug that in. That will be on the quiz. So here's my advice to you. The rest of the time is for you to work. I would make sure before you leave this class that you can do number 12 from last night's homework. If you look at today, it's mainly just graphing. Oop, I got the wrong one. If you look at today's, it's mostly just graphing. But if you look at the 10 and 11, 10 and 11 are the ones we did in class today. I would do those first before I get to anything else. So that way, when I leave class, I know that I can do what we need on the test. Everything else is just practice graphing. There's some weird oddball ones, but we don't have to worry too much about the oddball ones on this quiz. But before I leave today, I'd make sure that I can do both of these. Any questions about what is expected of you today? Okay, the rest of the time is yours to work. Ask lots and lots of questions.